Hi there everyone, welcome back to Cody's Lab. 1 million. It's a crazy huge number. That's like 5 times the population of Salt Lake City, and all those people have saw my videos and thought to themselves, I'd like to see more of that. And so they click subscribe. I have now 1 million subscribers. And to celebrate, I'd like to make a gold play button. YouTube will be sending me a gold play button, but I kind of want to make one of my own. Now, of course, a gold play button the size I'd like to make out of pure gold would cost around $50,000. I'd like to be able to make one of those at some point, but for now I think I'll try a different gold colored metal, which is perhaps a little bit more interesting, and that is Ceasium. Ceasium is a highly reactive alkali metal, so this ought to be pretty interesting. So YouTube did eventually send me the silver play button. I think I got it when I had over 500,000 subscribers, but you can see, there it is, right here. Now I think what I'm going to do is use this as a mold to make a Ceasium play button. Oh, I see. The whole thing comes apart. Well, there it is. Here's the play button. Let's go make a silicone mold of it. Here's hoping that silicone doesn't react with Ceasium. Oh, that's perfect. Still got some bubbles and voids, but you know what? I don't really care. It's a general play button shape that I needed. So I've welded together some pipe and some caps, as you can see, and I built me a little retort here. And to this I'm going to add some lithium. I think I'm going to stuff in maybe 10-15 grams of lithium. That's enough to reduce nearly 200 grams of cesium, so this will be a little bit excess. Now I'm following the lithium up with some cesium chloride. I'm going to add about 250 grams here. And to finish, a tiny bit of mineral oil, just to displace the oxygen. So I got the tort in the fire. Hopefully the cesium will vaporize and condense in this pipe and wind up down here in this glass bulb, which is full of mineral oil. Now this here isn't sealed on super well, as you can see. I just got this rubber gasket there. But it should keep the air out. So let's turn on the fire. In order to get the cesium to start distilling, I need to get this whole thing right here around 1200 degrees Fahrenheit. Hot enough to melt aluminum. Looks like the mineral oil is starting to distill over. Looks like the cesium is beginning to react. You see it, some cesium vapor is getting down in there. And it just blew something up. Shoot. It appears that we had a boil over. That's actually not cesium that's burning right there, that's lithium. Like some lithium came over into the flask. Not sure what to do about this. Put out the fire for one. So I think the problem is that I tried to do too much too quickly. So as you can see, I've scaled back the size of the distillation apparatus, and I'm using a more constant heat source. So I'll have to run this several times, but I know this setup will work because I've done this before. If you haven't already seen, I got another video which I'll link over here in which I made cesium at home. Let's let this run and see if it works. If it does, well, I'll just do it 6 more times. There we go. That's the way to distill cesium. Looks like the distillation's about done, and that's a pretty sizable chunk of cesium there. But still not as much as I want. So here's the play button mold, and here's the cesium that I've produced. So let's take this cesium out with a syringe. Oh, before I do that, let's actually put some mineral oil on the play button just to keep the cesium from reacting to the air, or maybe even the silicone, because this cesium is just so reactive with everything. Okay, let's pull some of this out. Look at that. That pretty. Nice gold color to it. Let's just squeeze it onto the play button. No, under the liquid. So here's the second squirt of cesium. You can see that the cesium is already setting up a little bit, so I'm going to have to work quick here. That is a lot of cesium. And supposedly it's more valuable than gold, even though I produced this quantity here for probably about $200. Not including my time, of course. Okay. The top surface isn't quite flat, but I think I can just warm the whole thing up and get it to all melt again. So I've turned up the temperature and remelted the cesium. So I'm going to actually take this pair of scissors, and I'm going to scrape at it a little bit. So when I run this along it, it seems to just kind of repel the blade. It doesn't actually like skim and form a shiny metal. That's interesting. Most metals you can skim it off, but this just kind of, I guess the surface tension relative to the oil is really high. Okay, well, at least I got it flat, and I've probably knocked out most of the bubbles of oil. Okay, so the cesium has cooled off and solidified again. And you know what? I'm going to brand this as a slab made by Cody'sLab. So, a Cody'sLab. Let's see. Okay. C-O-B. There we go. Cody'sLab. Alright. Now let's turn this slab of cesium over and see if it turned out to be a good play button shape. Okay. So, not as shiny as I'd like, but there it is. Play button made out of cesium. I just broke it. Oh dear. Alright, back into the oil. Ceasium, the metal that melts when you poke it. Look at this. I'm dipping my finger into liquid cesium. It's really not a problem because there's so much oil around here. It feels cold. There you go. That's a first. So I have repaired it. Let's see if I managed to make the other side any more shiny this time. Hey, I'd say that's better. Look at that. Okay, let's keep this coated in oil. I'm going to transfer this over to a jar. There it is. So I weighed the jar before and after putting the play button in, and there is 84 grams of cesium. The world's only YouTube play button that is so reactive it must be stored under low oxygen mineral oil. Like, even baby oil will react with this thing. But now we get to go throw it in a lake. Okay, here we go. Ceasium play button. 3, 2, 1. There you go. 3, 2, 1. There you go. So there you have it, a huge chunk of cesium going into a pond doesn't make all that big of an explosion, which totally makes sense to me, because in chemistry, reactive does not necessarily equal energetic. You see, the amount of energy you get back from reacting an atom of sodium with a molecule of water is roughly the same as you do when you react a huge atom of cesium with the same molecule of water. I mean, cesium does actually release a little bit more, but it's not significantly more. But what is significant is the fact that cesium is a very large, heavy atom, and so there's not very many of them in a gram, which means my 80-gram sample of cesium only had about the same number of atoms and the same energy release as about 10 grams of sodium, approximately the same amount of sodium that Grant Thompson and I flushed down the toilet. The whole reactivity thing is just the fact that the cesium will react with things at a much lower temperature. It requires a lower activation energy to strip off electrons, which means that cesium will react with air violently at room temperature, whereas sodium, you'd have to raise its temperature by around 600 degrees to get the same kind of reaction. So I hope you enjoyed. I'll leave you guys with a high-speed video of lithium mixed with cesium reacting with snow, and I'll see you next time.